In this tutorial I'm just gonna create a small virtual machine. It won't have no real output apart from showing the RAM in a yes box, and it will show the register's contents in the text box, and then you'll be able to manipulate different registers. Now if you don't know much about the architecture of a computer, the key parts of a computer is the CPU and the RAM. Now the RAM in code, you could just think of it as a byte array. It's just a list of numbers of sort, and you can just store and do whatever with them. Now with high level programming, it manages it all in that for you, but in your level code it's nothing. You can just manipulate each byte by byte and so on. So we'll have a byte array for RAM, and then for the CPU we'll have a while loop and a switch inside it, and then that'll operate like a timer, and the switch will operate like the logic and the circuitry behind the CPU. So first thing we want to do is load a file byte by byte into a byte array. So on form node, actually we can create a new class for this, and I'm going to call this virtual core. Now for this tutorial I'm hoping you have some C# experience, otherwise you might find this difficult. I'm not going to go over it too much. The aim of this video is to teach someone with some C# experience how the CPU works, and more to the side of how to create a CPU in code. Now as I was saying, you need a byte array. That's our memory, and then I'll create a function called tick, and this will do calculations and such. So basically it's a switch, like I was saying before. And before I continue, I'm just going to create a uint, actually too short, IP. Now IP is an instruction pointer, and this is a register. This here would be the CPU tick that happens every time the crystal sets off circuitry and such. And here's the random access memory. So in here we're gonna get a byte of data from the memory at the location of the IP. Now this is one of the most important registers. It holds the location in memory we are at currently, and every time the CPU is given a new instruction, it's basically going to tick and then get the byte depending on the IP location, and then depending on that it will do different things. So I'm just going to set up a default case. Now for each case here we can have a different operation, and this will be the actual hexadecimal digit, or you can do it in decimal, that is read from the file. So we're going to actually want to load this up and then put it into our program. So over here at the top I'm just going to do virtual core virtual machine equals new virtual core, and when this loads we're going to want to load the virtual machine. Now just for this tutorial I'm just going to load from a file called load ram.bin, and then this will be a file so that we can preset the contents of the RAM. Now this function does not exist yet. We're going to actually code this in here, and when the computer starts up it has a master boot record, and that's the first sector on a floppy or such, or a hard drive, and that's loaded into memory. But for this we're just going to load the full file or whatever into memory. Normally on a computer in the first 512 bytes you'd have to load the rest of the bootloader and such. Now the data we're going to put through the load function here is here as a string, and this is the location we're going to put at. So here I'm just going to string location. So we're going to want to check if that file exists before we do anything. So file.exists location, and let's resolve that. So we're using the system.io. So file exists, we're going to want to actually load it into the memory. So we're going to actually set the memory to the file dot read all bytes of that location. So this thing will become the size of the file. So in our file, we're going to want to do padding and search for the actual, to give the size of the RAM we want and the starting conditions. And then down here we can actually create the different functions for it. In the next video we'll actually create more useful functions and such, but for now, just to show you effects, and before we finish, we're going to have to create some more registers. I'm going to call this AX, and I'm just going to copy and paste this, and it's going to be BX, CX and DX. We're also going to have a register called SP and BP, and this will be for much later in the tutorial. And we'll also have DI and SI, and this is the source and destination. SP is stack pointer and base pointer. These are the general registers here. I'll just call these special registers. Now for these we're not going to worry about for a while, but we'll do some stuff with these. Now case, these are all the different functions. So each it's like using loads of if statements and such. So depending on what the byte is, we can do different things. So if the byte contains 1, we can load the next byte into AX. So AX equals memory IP. Now this would actually be the same number what's here, and we don't want that, we want the next one. So we're just going to increment the IP, and then when we use IP here, it's going to actually be the next byte. And because we've also incremented it, the next time we go into this switch, it will be the next instruction. But we don't want it to be that, so after the switch we also need to IP it again, plus. And this is basically after each instruction it's going to increment 1. And this here is just extra data because we're collecting data out of the RAM. Now this basically set AX to whatever's in the memory straight after, so we can test this out. A program here, HXD. This is a hex editor, and it will allow you to write pure hexadecimal files. Now you will need this. Here you can have 0 all the way to F, and it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have A, B, C, D, E, F, and then it'll go to 10, 11, and so on. But each two hexadecimal digits is 1 byte. So if the function is 1, we don't put it as 1, 0, because that would be 10, we'd put 0, 1. And then here would be the next byte, and so on. So that would call this function, and then we want to put the next digit into that register. So I'm just going to set I set 50 into there, and then after that we want to enter program, so just put 0 and that'll go to the default and then break. But something else we're going to add here is a bool, and we're going to call this power and then put it to true, and then here power to false. And then basically if it's if it's on out of power, we won't execute anything. So that'll basically be the end of the program. So just for now, just put if power. That'll be moved somewhere else here, but this will only execute this if there's power. But there's that incrementing thing as well, so we'll just put it like that. And then if there's no power, we won't do nothing. So if we run this, it should load ram.bin from this file. So I'm just gonna open file location. So ram.bin, and copy that, open that, paste it, and it is, yeah, so it should load up and be fine. Now down here, just gonna do console dot, it's from yeah, just leave it as that for now. Actually, I know, it's fine. In here we're gonna actually start working on the display. So I'm gonna have to use box here, and it's gonna just display our RAM. And we can use a timer to update this all. GUI update. And just for just being simple for first program, I'm just gonna put public on most of this. Just because I'm lazy. Actually, I'm not worried about that. We won't really use that. So virtual machine dot tick, and we're only gonna actually do this if power. So we're already getting rid of this. Oh, so it's GUI update. What am I putting there? I'll create another timer. This will be for the clock, and this will basically call the tick. And we're going to clear this box. One sec. Oh, where's this view? This box, yeah, that's what I need. Gonna clear that, and then for each so basically just gonna go through each byte in memory and just gonna add it to this box. Yeah, we're also going to want to add some text boxes for registers. For now, just do IP and general registers. Look at now these are just going to be read-only registers. We don't need to modify these. This is AX. This here is just going to start and stop the timer. So we're basically just going to trigger between if it's on and off. So if it's enabled, we're going to turn it off. Otherwise, turn it on. And let's going to set the button .1.text equals the opposite, so turn as stop and start. This is going to be like a manual tick. Now to set the registers. So we know the name, we're just going to do change the name of these. IP text box. You can change these to whatever you want. And then basically we're just going to set each of these to the value. I'll say to text. So this is gonna continue update the user interface, and also run the virtual machine from the code we give it. Now we need to apply it some code. Yep, we're applying it code. Wonder what happens now. Nothing. Gotta start it. We want the GUI update to always be enabled. Yep. So see if it works. Tick. Yep, it's set the register to 80. Was it meant to set it to 80 though? 50. And we got 80. at least it's doing something. Backwards, oh, and hexadecimal as well, yeah, so hex 50 to decimal is 80, that's correct. It's working. And then it ends the program. But, yeah. Now we need a reload button. Eh. Well, I guess it's the same thing, so... yeah, let's put the reset button here. Now, if you don't understand what this is doing, it's basically allows us to add functions and manipulate data. Now, you might think this is not much, but later on we'll get into a stack and such, and then you can basically store a large amount of data in a memory using stack. And this is actually how CPUs work in the real world to power your computer, and it runs millions of instructions like this. But C# won't run as many, but you can simulate it so you can get an understanding of what's going on. One more thing is you're probably going to want to reset your registers just now for temporary into the next tutorial. You can just place it up here on your yode. So just set it to let's be easy. That'll set all the registers, and we want the instruction register as well, otherwise the program will be running and it'd end the program again. And we'll just leave the rest for now, but you can add them on if you want as well. And yep, it worked. And then reset. And didn't do nothing. Did the program just do anything? Yep. The power state. So we want to reset the power as well. And we'll do that after we add memory. Let's try now. Yep, you can reset and it stop that and then reset it, and it works. It's good.